So, like I said, that the OSI model really breaks down how the network stack works, and without it, we couldn't have computer-to-computer communication, computer-to-switch. We have to have this all synced up for proper communication to take place. And within like an operating system or device's operating system, there's a stack built in, and they have to be compatible to allow for communication to take place. And really the only level or the only places where they probably wouldn't be compatible, which would be like the physical or the data link, and we'll look at why. Now there's another model that's called it's called the DoD model. Some people call it the TCP model, and that existed way before the OSI model came around. And it explains how TCP, that protocol which is at the transport level, actually works. Where OSI has 7 different layers, the DoD model only has 4. And when you look at it, you'll see that the bottom is network access, which means how does the traffic actually get onto whatever communication, whether it's, like I said, a copper wire or fiber. There's internet, there's host-to-host, and then it'll just say application, because above transport, TCP doesn't care about anything that's above it, any applications. That's just applications. It works at the transport layer and down. So the OSI model actually covers all of the layers, not just basically one layer and down. It covers it from A to Z. So you'll have to know that for the exam. You'll see these in different literature, and especially people who've been around networking for a long time, they seem to like the TCP model better. But the big difference is that OSI model can be used for a lot of different protocol sets. TCP is only for TCP. So the OSI model is a model to allow a lot of different types of communication, a lot of different protocols to be able to work together. Now, as the actual data goes down the network stack, it's called data encapsulation. And we will go through each one of the layers and talk about the different protocols that work there, the functionality. But what data encapsulation means is that, let's say you write an email. That's the data payload. That's the user data. And then that is actually going to go down to the next layer. The next layer of protocols are going to put a header and potentially a trailer on that. It goes down to the next layer. The next layer's protocol will put another header, potentially a trailer, and it goes continuously down the whole stack, and it gets larger and larger until it's really called a frame. Once it gets down to the data link layer, it's referred to as a frame. And the reason it does this is because once, let's say you send the email to me, now once the frame actually gets to my computer has to do the opposite of that. So at the data link layer, that protocol is going to take the header off, the trailer off, and know how to process the data and know what protocol to put it up at the next layer. Then the next layer's protocol is going to take the header and trailer, and those are instructions. Really, when you say that a header or a trailer is being put on a packet or a frame, those are instructions. So when you write an email, the email data is actually the payload, and it's going to go down the whole stack, and each one of the protocols is going to put its own instructions on it. So once it gets to my computer, my protocols are going to take the header and trailer information, know how to process it, and then it goes back up my network stack till it hits my email client, and I can actually read the email. So we're going to go through each one of these layers, but remember, each one of these layers is actually putting something on the data that's going to go over the wire.